P-charts means that we look for fraction. So this one is very important. So that fraction. P means actually proportion or fraction. So you can say a fraction chart. So generally you can use go and no-go gates. Let me show you how it works. So you have, so this part is, this one is the no-go, and then you have the go. So you check the quality of the part. It should not pass in the no-go condition. Don't pass. And then in go condition, it should pass. And this way, you check the quality. Or you can say that you check defect, the tolerance, or you can say. If it passes from no-go condition, then it is defective. If it doesn't pass from the go condition, then it means that it's also defective. This is how it works. And this is how you get the data. So this one is used to get the data. Okay. So as I said, we have the fraction, and then we can use the go and no-go gates for our case. But for the p-chart, we need to use lots of samples, at least 250 sample size. So the sample you take, it should contain, sample should include at least 250 items. Why is that? Because we want to include the non-conforming products as well. So you increase the number of items or products to check so that you can include the non-conforming products as well. So this is a simple example for the p-chart. So we have a batch of 20,000 parts. So batch means that this is just a mass production, yes? And we are selecting sample sizes 400. So in each sample, 400 parts. And then we have 14 samples. So you can see the total is 14 samples. And we inspect for defects, scratches, indentations, whatever. And then the question is that draw the p-chart and then interpret it. So you can see we have 400 and 15 of them is non-conforming. You can see these products that cannot be used. Okay. We have the sample 2, 18, sample 3, 17, and this way we have the count. So this is from out of 400. So out of 400. Okay. And then this is the step 1. We collect the data and then count the non-conforming items. Step 2 is that we need to find the p-value. P is NP divided by the N. So 15 by 400, 18 by 400. This way, so this one is 15 by 400. This one is 18 by 400, 17 by 400. We check the proportion. You can see that the proportion of defective items, defective products over total products. This is what we check for. So we check the number of, or the proportion of the defective products versus the total products. And then we draw the chart. To draw the chart, we find the center line p-value, which is the summation of the NP values, sum of these NP values, and divided by the total sum of these N values. this will be the average p-value. Or you can just go here and then sum these p-values, and then let me just show you. You can do this way, sum of the p-values by how many of them you have. 14. So you can say that m is 14. M is number of sample. Okay, we have m. Okay, and then upper control limit is that p-value plus 3, and we have this formula, and then n is 400. You can see this is n value. Sample size is 400. And then we have the lower control limit. Let's plot it and see how it looks like. And this is very similar to what we did till now. Okay. So we have the P chart, and these are the data that we have. So we have the P values, as you can see, I calculated. And these are the defective products, and these are the sample. And if I just go here and add, n is 400, as you can see. This is the n. M is number of samples is 14. As you can see, this is 14. Okay, let's start with firstly the p bar, the average p value, and that will be equal to the average of these p values. Okay, and then it should be the dollar sign here, and then dollar sign here. Okay, this is the p value, p bar actually. Then I need to look for the upper control limit and then lower control limit. The upper control limit, that's equal to the p bar, the value here, plus the 3 times the square root of p bar, the value here, times 1 minus again this p bar, and then we divide the square root of n. So divide by the square root of n. The n value, it is 400. So that is, I will just put it 400. That's the n value. Okay, this is the upper control limit. And then let me see, it worked correctly. Yes, it works. And instead of 400, what you can do is that you can add the 414 and make it as n, and this one as m, and then make this one as a variable, and then say that 400 is equal to this one, and then m is equal to 14 here. So therefore, instead of 400, let's put this 400 value with the dollar sign, so that we can make a general chart instead of the for this example. And then LCL p bar is just the same formula with the negative sign. So we will have the same formula here, and then with the negative sign here. Okay, and then let me correct everything. So now it takes the H2 values. Let me correct it and then paste it as a function. So it takes this value, and then it should be the first one. Okay, then let's see. Okay, let me write the formula, because it takes this column here. So that p bar, this one, minus that 3 times the square root of the p bar, which is this one, times 1 minus the p bar value, and then divide by the square root of the n value. And this one should be with the dollar sign. Okay, this is the lower control limit. Okay, so let's check. So we have the square root of the formula here. Let's check this one. Then we have the square root of the formula here. Okay, this is the formula. Now let's plot it. This is the general plot that we always did. So there is not anything different than the ones that we did. So we will have, then we will have the p chart, and then we will have the p values here, and we will have the, sorry, the x is the samples, sample 1 to 14, then y is the p values. Okay, and then we will add, let me see, it shows, okay, so this is the p chart. Then we will add the central line and then upper and the lower control limit. The select data, we add the y values, this will be the center line, then okay, and then we will have the upper control limit, sorry, then y values, it will be upper control limit, and then x values will be the lower control limit. Okay, and then we can check this one. Let's make it as a solid line instead of the marker options, and then for this one as well, let's make it as a solid line, and this one as well, a solid line. As you can see, that is, we don't have any value that is outside the limits, as you can see, and also there is no any trend, as you can see. Some, this is random, yes, some is up, some is down. First 1 2 3 4 5 values, it looks like there is a pattern in the first 5 values, but it's not for sure. If the pattern was there, pattern, the first value should be here, so it should look like a pattern. But for this case, there is no any problem, everything looks okay, and it's inside the control limits. This is what it looks like for the this for the p chart, and whatever value here is shown, it is for the, it shows the non-conforming parts, the defective parts. You have to be careful here when you interpret. So it shows that how many defective parts you have in your manufacturing plan as a proportion. Okay, so let me take this chart here and then add a little bit comments on it. Okay, so we have the, this one is upper control limit, and this one is lower control limit, and this one is p bar, and the values here, these are the p values. Okay, and then we don't have, so the p values, I should note it again, the p values, it shows defective parts in manufacturing. How your defective parts look like in your manufacturing facility. You can see it is randomly distributed. That's okay, and everything is there in the limit range.